Hello guys, welcome you all need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot and we are learning a lot each and every day. Hope the same thing for you guys. So if you guys stuck anywhere, if you guys have any doubt, just ping in the comment section. We are here to help you. We'll take up your doubts from the comment section and we'll solve your doubts. And yeah guys, so if you guys are to this level, please make sure like you guys watch all the previous session videos so that you can have a continuation of what we are talking. Okay, so that's the thing guys. So hope everything till now what you guys have listened to us or what we have thought you guys are able to understand. As I again gonna mention, please make sure if you guys have any doubt, just ping in the comment section. We'll take up and we'll solve your doubts. Okay, so that's the thing guys. And one more thing, we are having 4,000 plus quizzes which are live in our YouTube channel. Please go and just give a try out of it. Okay, and subscribe to our channel because every day we are just posting a new video. So whenever we post the next video, you're gonna get a notification if you subscribe and press the notification icon. Okay, so without wasting any time, let us jump into today's session. So today's session is all about a continuation of image features and then detection, okay, of previous session. So please watch the previous session at least. Okay, yeah, let's move on. Small invariant feature transform, SIFT. Okay, let's understand this what it is. Okay, small scale invariant feature transform, SIFT. Detect. SIFT identifies distinctive key points in the image invariant to the scale and orientation. Okay, what it does means based on the features, it's going to detect, okay, this object is this much different than this one. Consider myself and the background, how it differs based on the pixel values. I'm somewhat darker when compared to the background. So it will detect me as a darker features, whereas the lighter features, it will detect the background. Okay. Then describe, it then creates a unique descriptor for each key point, enabling robust feature matching. Okay. For example, it considers me as a more pixel and this one is a less pixel. That is what they describe. Match. SIFT can reliable match key points between images, powering applications like object detection or object recognition. This is very important guys. I have said the point, right? Based on the pixel value, it's gonna recognize, okay, it is a human and it is a background, like that it's gonna do. So this SIFT, that is scale invariant feature transform, has this kind of step, that it has the detection, description and then matching step, by using which it can detect the object in a very easier, and it can recognize the accurate faces also. Okay, so yeah, this is how this SIFT works. Okay, yeah, sir, over to you.
Okay, so SIFT, okay, scale invariant feature transform. So there are three aspects to it. So we have to understand. First is detect. It identifies distinctive key points in the image. Okay, inverts them to scale and orientation. Then describes, then creates a unique descriptor for each key point, enabling robust feature matching. So that is what it is going to do. First it is detect, it will detect, then it is going to describe, and then it is going to match. Okay, so all these features will be, all these and this it is going to help, like in match it can reliably match the points between image, okay, powering application like object recognition, which we have already explained. So these SIFT is a very powerful tool in computer vision, which is going to help identifying matching key points between image, powering application like object recognition. It is going to enable robust feature matching. Okay, so this is the importance of SIFT. So keep learning deeply, guys. We are learning deep learning, and let's see you in the other section.
Yeah, guys. Let's move on. Okay. Um, so let's move on to the next slide. Okay. So surf, it's another feature extraction technique. Guys, we have discussed one thing. Okay, what we have discussed on SIFT. Now we're going to discuss something different, that is called a surf. Speeded up robust features. What is a fast key point detection? It is called fast key point detection as well as the compact descriptors. Let's see what it is. Surf uses a effective like Fusion based detector to rapidly identify distinctive key points. Guys, this is what it does means it just go for a glance of the frame and it will identify what are the features available. Okay, that is how this speeded up robust features works. Okay, then compact descriptors, the algorithm generates compact yet highly distinctive features descriptor for each key points. Okay, I will say this is a frame, it will go at a glance and it will get the features out of it, and using that only it's gonna create the descriptor as well as the object recognition. Okay, as much as speed it can, it does, and based on the object that is detected during the speed search, it's gonna do the recognition detection anything. So that is what all about this feature called as surf. Okay, yes sir, over to you.
Yeah, so Surf, it is speeded up robust feature. Again, a technique. It is fast key point detection. It is going to do that. And Surf uses the efficient Hassen-based detector to rapidly identify distinctive key points. Okay. And compact descriptors, the algorithm generates compact yet highly distinctive feature descriptor for each key point. So these are the aspects of surf. Okay, it is going to speed up the robust features detection and compact descriptors, and this is going to help to detect distinctive features. Okay, in the each key point. Okay, it is rapidly identifying distinctive key points also. So these are the main characteristics of surf speed up robust features. So let's move to the other section.
Yeah, sure sir, let's move. Okay, yeah, another technique. Guys, we are discussing about different feature like image features technique. We're gonna see next hug, that is histogram of oriented gradients. What is gradient? Hog captures the distribution of intense gradient within an image. I hope like you guys already know about what is gradient. Gradients is a simple thing. It's a shading of different colors in an image. First of all, we're gonna do that. Cells, the images is divided into smaller cell and a histogram of gradient is computed for each. Okay. For example, we are having this frame, right? Let us divide it into 4 cells. Okay. This one we're gonna apply kind of a histogram. This one histogram and this one. So like 4 histograms, and we're gonna compute the gradients out of it. Blocks. Group of neighboring cells are combined into a larger blocks to form the final uh, hello descriptor. That is histogram of oriented gradients. Okay, so we are having 4 kind of blocks right now. We're going to combine those together, so we will be getting a one block using which we can identify the final hog descriptor. Okay, so yeah, this is all about this hog image feature extraction technique. Okay, hope you guys are understand. So yeah, sir, over to you.
Yeah, so histogram of oriented gradients HOG, short term. So gradients, hog captures the distribution of intensely gradients within an image. I spoke about it, the complexity, the intensity of the image. Okay, it is going to do that. The hog is going to capture that density of gradient. Then cells, the image is going to divide into small cells, and histogram of gradient can compute for each. Compute, it would be computed for the gradients is computed for each. Okay, those cells. And blocks, group of neighboring cells are combined into a larger block to form the final hog descriptor. So that is how the histogram of oriented gradient hog works with gradients, cells, and blocks so that it captures the essential information from the picture or the video or whatever we are using in computer vision. So whatever image or shape is there, so it is going to help us to identify, okay, the intensity gradients within the image and other aspects. So it is really going to help us in terms of the intensity of the gradient and the, like what we talked about, the pixels, the dense pixels in the picture. So in technical terms, they have specific name, and this is the technique which is going to help us. And it will cells, the image is divided into small cells, histogram of gradient is computed for each. So it will be like, it will be, if you have seen those pixels, if you have seen, guys, so those pixels are also data, and it's like you can see the how much is the density, like when we have histogram of like if 9 number is the highest, then 6 and 3, so you'll see 9 higher because it has more units in it, right? Same way, histogram of, like if it is dense, it will have higher, that histogram kind of thing, the higher pixels, higher, so it will be that. And then groups, it is going to group blocks, it is going to group the neighboring cells for combined into larger blocks to form a final hog descriptor. That is how it is going to work. Let's move to the other section.
Yeah, sure, sir. Yeah, guys, putting in a simple way, hog is like a histogram oriented gradients where we're gonna have an image, we're gonna split it into number of blocks, we're gonna apply the histogram on top of it, we're gonna combine it, so we'll be getting the image features. Okay, I hope like this is a simple explanation, sir. As I explained in a good manner, like a better manner, like a detailed manner, I will say. Okay, so yeah, guys, this is one technique. I think we have discussed about 3 different techniques of how image features are extracted. Okay, let's move on to the next one. Okay, let's see what are the applications of image features and detection. Okay, first is object detection, guys. Identify and localize the objects within images, enabling applications like autonomous vehicles and surveillance. Okay, consider in a road we need to make a autonomous vehicle to drive. What it need to do first of all, it need to detect different kinds of things which is available in our roadside, right? There can be some dogs, cats that gonna be coming, so it needs to stop whenever it comes. So in order to identify those animals, we will be using technique called as object detection. Then we're gonna have something called as facial recognition. It is also one of the key important application of computer vision. Facial recognition, like it detect and recognize the human face, powering security system and social media tagging. Consider we are having something called as a smart attendance system. Whenever a student comes into the school, it detects a student face. Okay, this man is present. Okay, like a kind of smart attendance system which can be which can be detected with delivered and deployed by using this facial recognition. Next, image retrieval, matching and retrieving similar images based on their visual features, useful for search and curation. Yeah, image retrieval, something like a based on the features we can predict. Okay, this is closely similar. For example, we are having a something called as cat. Cat will be somewhat resembles to a tiger, right? Somewhat resembles. So this kind of image retrieval, that is a combination of things which is retrieved, is done by using this image retrieval kind of thing. This is also one of the application of image features and detection. Okay, hope you guys have understand this. There are n number of applications which is available for this one, guys, but like there is only 3. These are the top 3 applications that we can have for this image features and detection applications. Okay, so yeah, that's all about the over to you.
Yeah, so application of image features and detection. So object detection, identifying, localizing objects within image, enabling application like autonomous vehicles and surveillance. Then we can go for facial recognition, detecting, recognizing human faces empowering security systems, social media, and tagging. Again, we have image retrieval, matching the retrieval, like retrieving similar images based on the visual features useful for search and curation. So you can see like we have enough, like lot of database for Aadhaar. So you cannot make another Aadhaar because your fingerprints and your eye um, pictures have been detected and there's a database for you. You cannot get another Aadhaar. You might get changed this, that, but your data is there. So that can be used in future, guys. So the it will be like, if government will allow, I think they will directly connect the CCTVs with the your this thing, and if there is something, they will directly detect the person who is where, what is his activity and all those things will come in the future. In China it is already there. So same way, guys, so these are the application, and you can apply in n number of industries wherever you have these characteristics: facial recognition, object detection, image retrieval. So you can use, you need to have data and model and technology. You can apply anywhere, and infrastructure, IT infrastructure. So this is going to be a disruptive, and keep learning deeply, guys. Let's move to the other section. Thanks.
Yeah, sir, sure. So guys, this is all about the image features and detection. I hope like last session and this session we have discussed this as much as possible. We have discussed lots of algorithm related to image feature extraction and then some of the applications. Okay. Hope you guys have enjoyed. We have enjoyed a lot. So hope the same thing for guys. If you guys have any doubts, don't hesitate. Just ping in the comment section. We'll take up and we'll solve your doubts. And before ending, like we are having 4,000 plus quizzes which are available on our YouTube channel. Try to attempt it. Okay. So that's all about today's session, guys. Bye. Take care. We will all meet in the next session. Bye, guys.